Hey guys, right now we're going to talk about converting quadratic forms. So we have three different forms of quadratics. We have standard, intercept, or factored, and vertex form. And we're going to talk about how you can go from one form to another. We're going to start by taking standard form and changing it to intercept or factored form. So to convert a quadratic in standard form to intercept form or factored form, you need to factor, surprise, surprise, completely. So before we hop into factoring completely, we haven't quite talked about the completely part yet in this class. We are going to talk about it more in a later unit, but I do want to touch base. I have a factoring completely hierarchy that you can use to help you. So you should have done this in Algebra 1, so this is review. You should always check to see if there's a GCF first, and then from there, you see how many terms are left, and this is going to help you factor your factors. So if you factor it once, and then you need to see if what's factored can be factored further. So I'm going to explain the hierarchy a little bit. If you have two terms, you're in these scenarios. We haven't talked about all of them, but that's okay. If you have three terms, you factor it like a trinomial, like we've talked about using the AC method, or just that brain puzzle when your A value is 1. This also includes when you have higher forms, because this is still something that you can use the AC method on. This is still this what you can use that kind of brain puzzle on. It's just going to be parentheses, parentheses with x squareds instead. And then also if you have four terms, you group it. So this is just a brief run through of a factoring complete hierarchy. We are going to go into more depth on that in a little bit. But let's factor this. So we start with a GCF, a greatest common factor. So let's take a look. What do all of these things have in common, and what's the greatest thing about it? That is 2. So I can take a 2 out, and I'm left with 2x squared minus 5x minus 3. And now I need to see if this can be factored further, so I can turn it into factored form. So I'm going to use the AC method. So I'm going to, because I have an A value that's not equal to 1. So this is 2. That's 3. So I want two numbers that multiply to A times C. So 2 times negative 3 is 6, but we want them to add to negative 5. And that's going to rewrite our middle term. So I'm going to do equals, and then I'm going to do some brackets. That's actually going to be helpful. So 2x squared, keep the first the same, keep the last the same, and then I rewrite this with what two numbers multiply to negative 6 but add to negative 5? Negative 2 and negative 3 multiply to positive 6. That doesn't work. But we want two things that multiply to negative 6. So that's going to end up being negative 6 and positive 1 that multiply to negative 6 and add to negative 5. So it's going to be minus 6x plus 1x, rewriting that middle term there, breaking it down. And you could have changed the order if you wanted. I'm going to add parentheses because I have 4 terms now and factor by grouping on the inside. My GCF here is going to be 2x, and then I'm left with x minus 3. Here, my GCF is just 1, and then I'm left with x minus 3. So my new form is, okay, these are the same, so I've got x minus 3, and then what's left is 2x plus 1. And then I bring down the 2. So this is my new intercept or factored form. Next, we are going to go from standard form, starting again, to vertex form. To convert a quadratic from standard form to vertex form, you need to complete the square, everybody's favorite process. So let's hop into this first example here. So I'm going to factor it like we did before, just to kind of take out that 2. And it's the same one from above. But I get to this point, and I have an odd b value, and then I have a value that's not equal to 1. And as we've talked about in the past, it's not worth completing the square. It can be super helpful to be able to change different forms. In this scenario, when you have an a value is not equal to 1 or even an odd b value, it can get really messy, and it's not actually going to be a super helpful thing to change it to vertex form. So here in these two scenarios, I would not bother completing the square. So I wouldn't give you a problem like that to change to vertex form. Now, this one, on the other hand, let's take a look at it. This is something that we could change to vertex form because I don't have an a value and my b value is an even number. So the process is you take your b value, you divide it by 2 and square it. And that's like what you add to both sides. And in this circumstance, when we are completing the square, what it's going to look like is a little different than the way we've seen it before, because I'm not gonna deal with both sides of things. Instead, I'm gonna do equals x squared minus 2x, and then I'm gonna leave 2 spaces and put the plus 4, and I'm gonna add it and subtract it at the same time. So I'm gonna add, so let's first find out what my b divided by 2 squared is. So that's negative 2 divided by 2, all of that squared. So that's negative 1 squared, which is 1. So I'm adding 1 and I'm subtracting 1. I'm always going to do the adding first because this becomes, right here, this is going to be my perfect square trinomial, which is x minus 1 squared. You can find that by taking the square root of the final term and then matching it with the negative of the middle. Or I like to just take the b value, divide it by 2, and that's what goes there. And of course, that's how we designed it. If you were having trouble figuring this out, you could factor it. And then here, we just combine these. So this becomes plus 3. And hey, we are in vertex form. Our last two conversions are very, very similar. We're going to take vertex form and intercept form, and we're going to change them into standard form. The process is the same idea. So to convert a quadratic from intercept form or vertex form to, that should say, standard form, you need to multiply everything out and simplify. And now that I noticed that mistake, I'm sure I made that mistake up here. So this is standard to vertex, standard. Oh, I didn't. Look at that. Good job, Miss Marshall. Only the one mistake right there. And we're just going to multiply everything out. So here, in this circumstance, we need to be careful because we need to multiply out the binomial squared. We have to do the whole FOIL thing. And I know people have asked me about this before because some people like the idea of distributing this 3 here and distributing it there. Just be careful. The 3 can be distributed to this first term, but it can't be distributed to the second term because it's getting double distributed then. So you can either do that first and then multiply what you get there. I like to do this part first. So I get 3 times x squared plus 2x plus 2x plus 4 minus 5. And then those I'm going to combine. If you're comfortable, you can jump from that step to that step. I'm going to distribute the 3 now. Combining those like terms. And now that's in standard form, vertex to standard. Now, same idea here. I'm going to do this part first because I like to do it that way. Going from intercept to standard, I'm going to keep the negative 2 out front. X squared plus 5x minus 1x minus 5, combining like terms. And then distributing. And now you are in standard form. And we have done all the different conversions there. And that's all we have. Have a good day, guys.